Hi students, today we will discuss KCET level problems on determinants. Here the first very important concept based on a 2 by 2 matrix, that is if A is a square matrix of order 2 by 2, that is ABCD, then this equation is very important, that is a square minus of a plus d into a plus det a into I equal to 0. So the very important useful equation. If a equal to a 2 by 2 matrix ABCD, then a square minus of a plus d into a plus det a into I equal to 0. Right. Now, for suppose coming to the questions, how they will ask questions in KCET exam. The first one, if a equals to 2 minus 1 minus 1 2. Right. Now here we need to find the value of a square, and they will give options like 4a minus 3i, 3a minus 4i, a minus I and a plus I. Like this they will give the options. So in this case, we have an equation that a square minus of a plus d into a plus det a into I equal to 0. So here det a equals to 4 minus 1, that is equal to 3. So from this we will get an equation as a square minus of, here a is 2 and d is also 2, a plus d, 4 into a plus 3i equal to 0. So a square equals to 4a minus 3i. Like that we can solve the question. Now from this formula, or suppose coming to the next question, if capital A equals to 1, 2, 5, 4, then what is the value of a plus I into a minus 6i? Now coming to the simplification, if you multiply a plus I into a minus 6i, you will get a square minus 6ai plus ai, that is 5a minus 6 into I square, so that is nothing but I. So if you multiply this, you will get this equation. So that what is the equation of this? So we have that equation like a square minus of a plus d into a plus det a into I is always equal to 0. So that what is a here? 1 and d is 4, so that a plus d equal to 5. From that matrix, det a equal to 4 minus 10, that is equal to minus 6. Now we can substitute in this equation, so that what will get? A square minus of 1 plus 4, 5a minus 6i equal to a null matrix 0. So the answer for this question is null matrix. Now move on to the next question. For suppose in the exam they will ask a question like this: 1 0 minus 1 7 and a square minus 8a plus ki equal to 0. Then the value of k, need to find the value of k. So clearly here we have an equation like a square minus of, here also a plus d into a plus det a into I equal to 0. Now what is a? 1, d is 7. Clearly det a equal to 7 only. 1 into 7 and minus 1 into 0 will become 0. So you can substitute the rest of the values here. Minus 8a plus 7i equal to 0. This is the required equation. So now if you compare, what is the value of k? 7. So k equal to 7. Right. Now move on to the next question. For suppose if a equals to 2304, then a square minus 5i, required a square minus 5i. Right. So this one you can solve normally by finding a square and 5i. So for suppose a square equals to what? 2304, 2304. Because we can't solve this question by using that formula, because of what? Det A is here 8, so but here it is not possible, 5i is there, so I can solve this question normally. So here what will get? 4, 2 3s are 6, 18, 0, 16, that is what a square, and we need a square minus 5y here, that is 4, 18, 0, 16 minus 5i, so that here it is minus 5 minus 0, minus 0 minus 5. So the answer is minus 1, 18, 0, 11. Okay, like this questions are there. For suppose in this determinant, some of the questions are very regular. We will discuss that type of questions. Firstly, the roots of the equation. Root of 0, x 16, x 5, 7, 0, 9, x equal to 0. Need to find the roots. So when you are solving this determinant, we can choose this column to do the determinant, because of here 2 zeros are here, and we can change the signs like plus, minus, plus, so that the equation you can solve using minus x into x square minus 144 equal to 0. So that clearly x equal to 0, x square equal to 144. So x equal to what will get? Plus or minus 12. So the roots of the equation are x equal to 0, minus 12 and plus 12. Now move on to the next question. The value of determinant of x plus y, y plus z, z plus x, x, y, z, and x minus y, y minus z, z minus x. This is what we need to find. Now in this case, this type of questions, by solving the slightly different determinant, it will be very lengthy. So you go with value substitution. That is, for suppose if I substitute x equals to 1, y equal to 1, z equal to 1. Whatever we can substitute, there is no problem. I will choose x equal to 1, y equal to 1, z equal to 1. So that in this determinant, the third row, all the elements will become 0. So if any row, according to the property of determinants, if a row or a column values all zeros, the determinant value is 0. So the answer for this determinant is equal to 0. Like this, for suppose we have another question, very regular question, 1 log y to the base x log z to the base x. Next, log x to the base y, 1 log z to the base y, log x to the base z, log y to the base z, and y, 1. Now when you are solving this type of question, here also we can go with the value substitution. Now here we can't substitute x equal to 1, x not equal to 1. We have to substitute, and no negative values accepted. Negative values we can't take because of it is a logarithm. So we can keep this one in mind because of x not equal to 1, y not equal to 1, z not equal to 1, because of those are in base. We know that if for suppose in case of this, log x to the base y is nothing but log x by log y. If you substitute y equal to 0, log 1 will become 0, we will get 0 by 0 form. So I will take some different values, then x equal to 10, y equal to 10 and z equal to 10, so that this will become 1, and if I substitute 10 to the base 10 is nothing but 1 only, 1, and here all the rest of the elements also will become 1 now, because of if I substitute 10, this will become log 10 by log 10, so 1. So all the rows, all the columns equal, so the determinant value is 0. Now move on to the next question. This is also by seeing this question is a very lengthy question, but it's a very simple question. R 2r minus 1, 3r minus 2, x, y, z. Here n into n plus 1 by 2, n square, n into 3n minus 1 by 2. To solve this question, and the question is, need to find sigma r equal to 1 to n dr. Okay, instead of substituting up to n values, I'll assume one n value, that is for suppose n equal to 1, here n equal to 1. In case of n equal to 1, here r value starts with 1 and ends with 1. So r equal to 1, n equal to 1. So this is my substitution here. So that here delta 1 is the d1. So n number of values you can take, there is no problem, but I stopped n equal to 1. So what we will get here is, if r equal to 1, this one will become 1, this will become 1 and this will become 1, and here there is no change, x, y, z, I am not assuming anything. And here n into n plus 1 by 2, if I substitute n equal to 1 here, 2 by 2 1, and this is n square 1 square 1, 3 minus 1 2 by 2 1, so this one. See, if you observe, two columns are same, so the determinant value straight away equal to 0. So like this we can solve the question. And the very regular question in the determinant is like determinant of adjoint A. For suppose the question is like, if A is a 3 by 3 matrix and determinant of 5 times of adjoint A equal to 5, need to find the value of det A. It's a very regular question. And to solve this question, we can use two formulas. That is, first one, determinant of Ka is k power n into det A, the first one, and the second one, determinant of adjoint A equals to det A whole power n minus 1, where n is the square matrix of order, right? First of all, it is in the form of Ka. So I can write that one as k power n. So n is what here? 3. In this question, n equal to 3. So 5 power 3 into determinant of adjoint A equal to 5. And one more thing, determinant of adjoint A we got. So determinant of adjoint A is nothing but det power n minus 1. N is 3, so it is 1. Here clearly det A square equal to 1 by 5 square, so that det A equal to plus or minus 1 by 5. Like this we can solve the question. And the most very important question, by seeing that it is a very lengthy question, 1 MC1 MC2 1 m plus 1 C1 m plus 1 C2 and 1 m plus 2 C1 m plus 2 C2. So this is the question, and we need to find the determinant for this question. See, before solving this question, we can go with the value substitution. For a suitable value you can substitute for m. We can't substitute m equal to 0, we can't substitute m equal to 1, because of if I substitute m equal to 1, here this value will become 1c2. So I can't substitute m equal to 1, but I can substitute m equal to 2. Right. If I substitute m equal to 2, then what will get here? 1. So this one will become 2c1, this one will become 2c2, right? And here 1, 3c1, 3c2, 1, 4c1, 4c2, right? So that here clearly 1, 1, 1, 2c1 is 2, 3c1 is 3, 4c1 is 4, 2c2 is 1, 3c2 is 3, and 4c2, 4 3s are 12, 12 by 2 6, right? Now we can directly solve the determinant, there is no problem, or else we can do the row operation also, plus minus plus, so that here 18 minus 12 minus 1 into 12 minus 4 plus 1 into 6 minus 3. So 18 minus 12, 6, 12 minus 4 is 8, minus 8 and plus 3. So this is 9 minus 8, the answer is 1. So like this we can solve the question. And one more thing here, the determinant and lies in the interval. This type of questions also they will ask. One question is delta equal to 1 sin theta 1 minus sin theta 1 sin theta and minus 1 minus sin theta 1. Okay. So if you observe this carefully, instead of solving directly, I can do like row operation first, that is row 1 gives row 1 plus row 3. Then delta, what it will become is first, this one will become 0, this one will become 0 because of sin theta minus sin theta, 1 minus 1, and here 1 plus 1, this will become 2, and the rest of the elements as it is, minus sin theta, 1 sin theta, minus 1 minus sin theta 1. Now I can do determinant based on the first row itself, and this will be sin plus 2. So the 2 into what will get here, sin square theta plus 1. Now we need to find the range of this delta. Clearly we know that sin square theta is always ranging from 0 to 1, because of sin theta is ranging from minus 1 to 1, right? So sin square theta plus 1 is ranging, add 1, sin square theta plus 1 is ranging from 1 to 2, and if you multiply with 2, 2 less than or equal to 2 times of sin square theta plus 1 less than or equal to 4. So clearly delta is ranging from closed interval 2 to 4. So this type of questions also they will ask very regularly. And one more thing, the maximum value, and one more very important question, find the maximum value for the determinant. For this delta max we need to find, and the question is 1 1 1 1 1 plus sin theta 1 and 1 plus cos theta 1 1. This is the question. See, instead of solving directly, I can use here also row operation, that is row 1 gives row 1 minus row 2. In case of row 1 gives row 1 minus row 2, I need to find delta max, right? Here this will become 0 and this will become minus sin theta, this will become 0, and 1 plus sin theta 1, here also 1 plus cos theta 1 1, no change. Now I can choose the first row only to do the determinant operation, and anyway this sign will again minus, so minus of minus plus, so that what you will get here is sin theta into 1 minus 1 minus cos theta. Minus 1 plus 1 gets cancelled, so we will get minus sin theta cos theta, that is what delta value. Now I need to find the delta max, right? So first of all what I am trying to do is I just divide with the 2 and multiply with the 2 sin theta cos theta, it will become, then delta equal to minus 1 by 2 into sin 2 theta. So clearly we have a sin 2 theta, right? And we know that sin 2 theta is ranging from minus 1 to 1, right? And you can multiply with minus 1 by 2 both this to this inequality. Here you will get 1 by 2 less than or equal to will convert to greater than or equal to minus 1 by 2 sin 2 theta greater than or equal to minus 1 by 2. Whenever we can multiply with a negative quantity to this inequality, that signs will change. So this is what the interval. Now here what is the maximum value is 1 by 2. So clearly delta max equal to 1 by 2. So dear students, these are the regular standard questions which are asked in KCET exam. So please go through this and find the shortcut methods. Okay.